It's 4 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Good. Doing good. Doing good. All right, and so probably the I mean, across all classes, I think the least attended lecture for any class is the one right before the midterm. So thank you guys for coming. But today's going to be a transition day, and so we're starting from now. We're going to be doing less problems on pen and paper, and then we're going to be doing a lot more in math instead. Okay. And so you probably already noticed this with our unit on the simplex algorithm, that the way that optimization problems are typically solved is through an algorithm, which is not so much an equation to plug in for, not so much that, but it's more just kind of a sequence of kind of logical steps that kind of goes one after. It takes a little bit to get used to, and so and I think that's kind of what I've been seeing with people in the simplex algorithm as well. Okay? And so a lot of the rest of the class is going to be very similar to that. The only difference is that for the rest of the class, we're mostly going to rely on MATLAB to do those calculations for us. Okay, we'll still do a little bit by hand just to make sure that we're kind of understanding every step of the algorithm. But I think kind of what's more important in the second half of the class is how do we take these algorithms and implement them in a way that MATLAB can use. And then I think more importantly, how do we take the results from MATLAB and how do we run with that? Okay. And so before we start any of that, before we jump into that second half, I wanted to take a day just to kind of review some just very basic MATLAB, mostly just how you define a variable, what an if statement is, what a loop is, and how these things work together. Okay, so we'll do a couple of examples as well. And reviewing MATLAB will be something of a continuous thing throughout the course. But before we even start, we have to kind of cover just the bare basics. So that was my plan for today, is to do kind of a very basic review of MATLAB, and then the rest of the class will kind of build. Okay, so some announcements before we begin for today. So homework 3 originally was due tonight. But I did push it back a day, so homework 3 is now due tomorrow night, just to give you guys an extra day. I know I know it's been kind of a hectic time for you guys this week, so hopefully that extra day was helpful for you. And I'll go ahead and post the solutions to homework 3 probably over the weekend. So homework 2 solutions I haven't posted yet, and so I am a little bit behind on those. So I plan on posting that either tonight or tomorrow morning. Depends if I remember to do it again. All right, so remember, so the next class is our midterm exam, and so please make sure that you are here in person for that on Tuesday, because there are no plans to offer the exam. And remember for the exam, what you can bring is you can bring your writing utensil, you can bring a calculator. Please do bring your calculator. Don't forget your calculator, as well as a cheat sheet. So you can have one 8.5 by 11 sheet of notes. You can write on both sides of it. You can write it. You can type it. Kind of whatever you. But those are the 3 things that you need for your pencil or pen, calculator, cheat sheet. Okay. All right. Any questions I can answer before we get started for today? Okay. All right. So let's go ahead and review MATLAB. So actually, these slides right here, we're not going to cover everything in these slides, just because I kind of took these slides from another elective that I teach, EGME 417. And so some of the aspects of these slides are not going to be relevant for our class, because we're not really going to be doing matrices. We're not really going to be doing linear systems as much in this class. It's really kind of more of a it's kind of more important to kind of follow the logic and if statements for loops, and that's kind of what we're going to focus this lecture on. Okay. So the beginning part here is why do we use MATLAB? But basically MATLAB is I would say the most common, I would say, educational programming language that's out there. Python is kind of coming up a little bit right now, but MATLAB I think is still the most dominant one, and it's the one that for the most part that everyone's learned probably at some point before. And it's relatively cheap. You compare it to like SolidWorks or ANSYS. MATLAB's only like $100. Well, it might be more now because of inflation. For a long time. Okay, so let's get to the basics of the basics, right? And so the first thing that we should learn how to do in MATLAB is to define a variable. Okay, So what is a variable? So a variable is a labeled entry that's used to store information. Okay? And so the way I think about variables is that they're almost kind of like containers, right? They're containers with a name on it, and then inside the container you can put any manner of data. Okay, I think most commonly we store values in a variable. Okay, more specifically a scalar value. And so once we define a variable, you can think of that variable as kind of representing that number that we assign to. Okay. All right, and so there are two things that you need for a variable. So first of all, you need a name for it, and then you also need its value. And the thing that connects it is this equal sign. And so if we were to define a variable, and so let's say we define a variable called scalar example. So remember, variable names have to be all one word, and so you can use underscores in the name to kind of connect separate words together. Okay. We have an equal sign, and then we have the value of the variable afterwards. Okay. And of course, don't forget the semicolon. MATLAB's unique in that you technically don't need a semicolon, but it just makes your program kind of obnoxious to read it. Okay. And so the way to read this statement here, and this is a theme that we'll use kind of throughout the course, is that we're going to take our code and kind of read it as if it were kind of an English statement. Okay. Because the thing with code, and I think people get kind of a little bit wrongly intimidated by code. A code is nothing more than, you can think of it as a set of instructions that you're asking the computer to do. Okay. And so the computer has its own language, and so hence the programming language that we're doing. But if you think of code as just kind of a list of instructions for the computer, I think it makes it a little bit more easy to understand. Okay. And so in this statement right here, we're basically telling the computer, all right, computer, we want to have this variable, and we want to have the value of 6. Okay. And so the way to kind of read this line of code here as kind of human speak is to say, define the variable scalar underscore example and set its value to 6. Okay. And so you'll kind of hear me do a lot of that throughout the class. There'll be times where you think I'm a crazy person just reading codes and as if I'm not talking to like a kid or something. But for me, it really helps kind of understand that. Okay. And so now that after you define a variable, you can then use it in lots of other expressions. Okay. And so most commonly what we're going to do is we're going to use them in arithmetic expressions. Okay. And so if you remember back from the previous page here, we have this variable called scalar example, and we set its value equal to 6. And so if you use that scalar variable in a mathematical equation like this, you can basically plug in the value of 6 every time you see the name of scalar underscore example. All right. And so, for example, we have this mathematical expression here. We have 3 times scalar example plus scalar example. That's basically the same thing as evaluating 3 times 6 plus 6. So 3 times 6 is 18, plus another 6 is 24. And so the result of this whole expression right here, this whole mathematical expression, is 24. And then another thing you'll see from this line of code is that we're taking this result, and so we're taking kind of the result of the mathematical expression, and then we're saving that into another variable. Okay. And so this variable, scalar underscore operation, is a new variable that we're defining, and we're storing the value of 24 in that new variable. All right, so once again, let's read this whole line of code here as kind of human speak or human language. And so what we're saying is to MATLAB, all right, define a new variable called scalar underscore operation and set its value equal to 3 times scalar example plus scalar example. Okay. And so then after this line of code here, we'll have 2 variables. Scalar underscore example will be 6, and then scalar underscore operation will be 24. Okay. All right. And so you can keep defining different variables, and that's fine to do. But I think one thing that I think will be kind of difficult later on is that we're going to actually reuse the same variable names and kind of reassign. But that's just kind of the basics of how do we define a variable, what do they represent, and how do we use variables that kind of map. This kind of forms the basis of a lot of the code that we're going to do, that we're going to write. any questions on defining variables so far? Okay. All right, so the good news about kind of what we're doing in this class is that, you know, we're going to be mostly working with kind of straight up numbers, and so we're not going to have to worry about vectors or matrices or any of that. So let's skip a lot of those examples here. Skip this one. Okay. All right. So once a variable is defined, you know, we can actually change its value, right? And so a variable's value isn't fixed after you define it. And so if we kind of take this line of code here, so if you kind of remember earlier in the lecture, we get scalar example. I'm gonna try to write with the mouse like in serial killer. And so remember earlier in the lecture, we had this line of code that said scalar underscore example is equal to 6. And so, you know, for everything below that line of code, the value of scalar example is equal to 6, right? But we're not fixed to this, and so we can change the value of a variable basically anytime that we want. Okay? And the way we do that is that we basically use the same kind of code that we did before. And so to change the value of scalar example, we just set another line of code. We said scalar underscore example. In this case is equal to 9. Okay? And then everything after that, the value for scalar example is equal to. And then we can use this. This trend as well. Right? So let's look at kind of this kind of snippet of code right here. And so if we define a new variable, and so we call this new underscore variable, and we set its value equal to 7. Okay. And then we define another variable called foo underscore dis is equal to 2. Okay. Then what we can do is we can then you know, change the value for a new variable based on foo dis. Okay. And so we say that foo dis plus 5 halves times foo dis. Then we have 2 plus 5 halves times 2, and so that'll also equal to 7. Okay. And so in that case, you know, even though we define the value up there, okay, for a new variable, we can change its value later. And you know, and this is a property that we're going to make use of quite a lot. Okay. And so when you're looking at kind of the values for variables in your code, you know, you have to think about kind of what's the current value of the variable based on where we are in the code. So you know, because the value of a variable can change. You know, all right. Another thing that we can do with variables is that we can update its value. Okay. And so if we want to just take the value of a variable and maybe just add 2 to it, or maybe add 9 or something like that, okay, we can do that using this this type of code right here. And so we take the value of the variable, we set it equal to the old value of the variable plus whatever. Okay. And so what this will do is that it'll take the old value here, which is 2, add 9 to it, and then it'll save that value into the value. And so once again, you know, we can kind of read this as if it were like an English sentence. And so the way that we can read this is that the new value of foo dis is equal to the old value of foo dis plus 9. And so again, you know, if you read this kind of like a sentence, it kind of becomes a lot more clear in terms of you know, what this line of code is representing. Any questions on this so far? Okay. And so, you know, variables kind of form, you know, like I mentioned, the variables kind of form the basis of a lot of what we do in programming, right? And we can use variables in lots of different ways. And so the first type of way that we can use a variable is to kind of permanently store some important information about the problem. And so typically these kinds of variables, we actually don't change their values, but we usually refer to them later on in the code. Okay. All right. And so let's say that we're writing a code that's interacting with some kind of cylinder in some way, right? And so maybe we're running like a simulation on a cylinder, maybe we're doing some kind of element calculation or something like that, right? And so maybe somewhere in the code, usually near the top, we'll have a variable called radius, where radius is the radius of our cylinder, okay? And then we'll reference this later in the code. set radius equal to 4, then usually we're not going to change that variable because that is something that's kind of a physical property of the system. And then later in the code, then we'll actually use it to maybe compute the area. So we say area is equal to pi times radius. Okay. Another way to use variables is kind of as almost act as kind of like temporary storage. Okay. And so if you think back to the way the simplex algorithm worked, right? The simplex algorithm kind of worked on a series of calculations, right? And along the way, sometimes it's useful to kind of store some certain pieces of information. So maybe the value of a non-basic variable. Maybe you can save that into a variable. Okay. And so a lot of times, we'll use variables for this sense to kind of store that information and then refer to it later in the code, but then maybe update that value later on. So maybe we move on to, we promoted a basic variable, we demoted another one. Maybe we update the value for a variable based on where we are in this simplex code. Okay. All right. And so, we're going to do a few examples kind of later today. We'll actually cover an example that we're, going to see in a couple of weeks actually. But I think that algorithm is simple enough to kind of so that you can see what I mean. And this last tip here is kind of really important. So, when you're writing code, you're going to be defining a lot of different variables throughout your code. And what's really going to help you when you write your code is to use descriptive names for your variables. It's very easy or very tempting, I think, to write a code with kind of very short variable names, just because you're lazy to type or something like that, and which I've been guilty about too. I'm always kind of lazy when I write code, but it really does help to actually write variable names that are actually descriptive. Okay, you can either use variable names that are consistent with the algorithm that we're running, so that'll kind of make it easy for you to kind of debug later on, or you can have whole words as your variable names. Okay, and so I give some examples here, and so I think what the tempting thing to do, when you're writing code that involves a lot of variables, is to use variable names like x, maybe x1, x2, x3. Okay. But if you think about it, if you have a code that's several hundred lines long and everything looks like an X, then it becomes a much more difficult ordeal to actually debug. Okay. And you could be like me too and curse at your code too. Typically not that helpful. Computers aren't well versed in human, so cursing at it and making it feel bad won't. Any questions on this? Okay, so we're going to skip this part. So we're not really doing much with matrices, and so I think that's kind of a good thing. Okay, so let's skip to this. Okay, and so in addition to using variables, we're going to make use of a lot of kind of kind of basic programming constructs. Okay, so I kind of call them constructs just because they're kind of part of the code, right? They're part of the logic of the code, I should say. And so the first construct that we'll go through is an if statement. Okay, and so the idea with an if statement is that when you're writing code, a lot of times you want to do something different depending on the situation. Okay, and a lot of times you don't know what that situation is going to be like until the code actually runs. And so as humans, we kind of do this all the time. So, if we usually a lot of times we're going to check something, and then depending on the result of that check, we're either going to do one thing or another. Okay. And so programs can do the same thing. And so we can give programs kind of the flexibility to do different things by writing if statements. Okay? Because if you don't write if statements, when you execute a program, it's going to do the exact same thing every single time. But sometimes you may want to do something different, especially when you're writing an optimization algorithm where maybe sometimes you're going to end the algorithm, but maybe sometimes you're going to continue. So one example of this would be in our simplex algorithm. And so there's one kind of crucial step in the simplex algorithm where we check to see if there are any negative coefficients in our objective function. And so if there are any negative coefficients in the objective function, then what we can say is that our objective function can be improved. And so we go and move on to the promotion, demotion, pivoting and all that stuff. Okay, but if we didn't have any negative coefficients in our objective function, then we can kind of terminate the algorithm there, and then kind of move on with stuff. And so in code, the way that you kind of check that is you write an if statement. Okay, and so mechanically it kind of works like this. And so you write if, right? And MATLAB is pretty nice because it actually highlights if in blue, and so that tells you that it's kind of a key word or a key phrase. Right? And then after the if statement, I personally like to use parentheses, just because that's just kind of how I was trained. But I know not everyone writes parentheses. Whatever you feel most comfortable with. Okay. And then depending on the result of this check condition, whether it's true or false, then we go into the body of the if statement. Okay. And so if the check condition returns true, then we go inside the if statement and perform the work there, run the line of code there. But if not, then we just exit out and we don't execute anything. So the key component of this if statement, of course, is the check condition. Okay? And so the check condition is something that can either be true or false. Okay? And it has to be written in a way to either return true. Okay, so here are a couple of examples, some very, very simple examples. And so let's say that we defined a variable. And so we defined a variable called needs underscore perfection. Okay? And we defined its value equal to 3. And so if we write an if statement, and so we say if needs correction is less than 5, then we set the value for needs correction equal to 5. All right, so the way to read this is that, if our variable here has a value that's less than 5, then we go in and correct the value of the variable. Okay? If not, then we can leave. And so for this first code segment here, since needs correction has a value of 3, and so we're checking to see if 3 is less than 5, so 3 is indeed less than 5, so we say this check condition is true. And so since that check condition is true, then we enter into the body of the if statement and we say that needs correction equals 5. Set the value of the variable equal to something else based on the if statement. Okay, let's look at the second example, which is very similar. The only difference here is that our initial value for check condition or needs correction is 9. Okay. And so we said that needs correction is equal to 9. So we check it in the if statement. So we check is 9 less than 5. 9 is not less than 5. So we say that this check condition is false. And so since the check condition is false, then we don't execute the code inside the if statement. So we basically just ignore everything here. Because our if statement returned false. And then we kind of just skip to the end of the if statement. And so the result of these two codes is so at the end of this first code segment, needs correction will have a value of 5. Whereas for the second code segment, needs correction will have a value of 9. And so even though inside the if statement we have needs corrections equal to 5, we don't actually execute that code because the check condition returned false. All right. And so that's kind of the basics of if statement. So yeah, to use an if statement, you have to give the computer a check condition or a condition to check, and then some code to run if that condition is true. If that condition is false, then we just any questions on this? Okay, and so the next kind of statement that we're going to learn is an else if statement. So the else if statement is kind of a branch off the if statement, okay? Except that it checked for a different condition, right? But sometimes, you might have a situation in your code where you're going to check one condition, and so if that one works, then you're going to do certain lines of code. But if that first condition fails, maybe we want to check a second condition within that same if statement, and then run that code. Okay. All right, and so the way to kind of read this here, and so we have an if, else if, and then end, right? So the end kind of denotes the end of the segment of code here with the if statement. If condition 1 is true, then what we're going to do is we're going to execute this line of work, this line of code here. So but if condition 1 is false, then what the code's going to do is that it's going to check condition 2. Okay. If condition 2 is true, then we do that work, which is this line of code here. But if neither of them are true, then we just exit, and so we don't execute any of these lines of code. So pretty straightforward, right? So we're checking two things. We check the first one first, and so if that one works, then we execute that part. We check the second one, and then if both are false, then we just exit. Okay. All right. And so kind of an interesting thing happens when both condition 1 and condition 2 are true. So both the if condition and the else if condition is true. Okay. And so you may think that, if both of these are true, maybe we execute both of these segments of code. So we do this work and we do that work. But that's actually not true. And so if the first condition is true, right, then what we're going to do is we're just going to do this work here. So we're just going to do the lines of code that are right underneath the first conditional, and then we're going to ignore everything else. Okay. Right. And so another way to kind of read these if statements is that it's searching for the first true condition. And so once that true condition is met, then we just ignore everything. Okay, so let's look at a couple of examples here just so that you can kind of see how this works. Okay, and so once again, we're going to use the less than or equal sign or the greater than sign to kind of check if something's true or false. Right. And so if we look at this first example here, we have a variable needs underscore correction. We set its value. And so the first thing we're going to check here is that if needs correction is less than 1, then we set needs correction equal to 1. And so once again, we're using variables here, so we're going to plug in the value for this variable. And so the value for this variable is 11. Okay. And so we're going to check to see if 11 is less than 1. It is not less than 1. So from there, we see that this is false. And so since the first if statement was false, we're going to go down to the second if statement, or the second else if, I should say. And so the next thing we check to see is else if needs correction is greater than 7. Once again, we're going to plug in the value for needs correction that was outside the if statement. So we're going to plug in a value for 11 here. Okay. And so if 11 is greater than 7, 11 is greater than 7. And so we're going to say the second part is true. And so since this else if is true, we're going to execute this line of code right here for needs corrections equal to 7. Okay. And so at the end of this code segment, our variable in question here, needs correction, will have a value of 7. Okay, let's look at another example here. Okay. And so in the second example here, we have basically the same code here, or the same if statement. The only thing that's different here is this first initial line. Okay. And so instead of setting needs correction equal to 11, we set it equal to 0 instead. And so let's go ahead and run through the logic. If needs correction less than 1, we plug in the value for needs correction, which is just 0. Okay. And so is 0 less than 1? Yes, 0 is less than 1. So we go into the body of this if statement, and then we set needs corrections equal to 1. So this line of code here gets executed. Okay. And then from there, after we've kind of found our true statement, the code doesn't even look at the rest of the stuff. So, we can kind of continue with this code, and we say else if needs correction greater than 7, okay, which in this case is false, and so even after we set it equal to 1 is not greater than 7, and so this is false. But it doesn't even matter, and so because the code doesn't even look at it, because what if said was that, all right, I have an if statement. My first condition was satisfied, so I'm gonna do what's inside this part of the code, and then I'm just going to ignore everything else in this if statement. And so the result of this code is that our variable needs correction has a value of 1. Okay. So that's what happens when you have kind of the true statement. Okay, so let's look at the last case here. So, again, very similar code. The only difference is the initial value for needs correction, which is set to 3 in this case. And so let's go ahead to the first conditional. And so our first conditional says that if needs correction is less than 1, okay, we plug in the value for needs correction, which is 3. Okay. And so we check to see if 3 is less than 1. 3 is not less than 1. 3 is greater than 1. So we say that this first conditional here is false. And so since that first condition is false right there, we don't even look at what's beneath it, right? And so we just ignore kind of what's beneath that part. Next, we check to see is if needs correction is greater than 7. So we plug in the value for needs correction is 3. And so we check to see is 3 greater than 7? It is not greater than 7, so this is also false. And so we don't execute this line of code. And so after this section of code, where both conditions fail, we basically ignore everything in the if statement. So by the end of this code, the value for needs correction is still the same as it was originally, which is 3. Okay. So that's the else if statement. So remember, you always kind of embed an else if into an if statement. Yeah, question. Good. Yeah, you can have as many else ifs as you want. So, and so you can have, I've seen cases in code with like 10 or 20. I don't think MATLAB. I think MATLAB might have it. And so some programming languages have another statement called a switch statement. And so that's kind of the more elegant way to kind of execute that kind of code. We have else if, else if, else if, else if, and so you can just do a switch instead. But else if works just fine. Yeah, in fact, we'll definitely have algorithm. We're gonna have the algorithm will branch in kind of 3 or 4 different directions. So we need to have 3 or 4 different paths. Okay. All right. So that's the else if. All right. And so the last thing with the if statements is to add an else statement. And so, in the case when all of your conditionals fail, so if your if statement is false, if all of your else if statements are false, maybe all 20 of them are false, maybe you still want your code to do something as kind of like a last resort. Okay. And so that's what the else is for. And so the else is kind of like the catch-all statement, where if everything else fails, you can do whatever's in the else statement. All right, and so the way to read this statement is that if condition 1 is true, then do this work. Okay. If condition 1 is false, then we ignore this code. Okay. Same thing for else if 2, and so if the else if returns false, then we ignore this code. Okay. And so in the case when everything is false, then we do work, I guess. Okay. And so the else statement only executes if everything else is false. If you have a situation where maybe let's say condition 1 returned true, right? If condition 1 were true, then we actually do execute this line of code here for do this work, and we ignore everything else. So that's kind of the important thing with the if statements is that, especially as you kind of get more and more complex with the else ifs and the else, we only execute one part of the if statement, okay? No matter what. And so even if condition 2 were true, we only do this first part. And we only do the else part if everything else was false. Okay, so let's look at this kind of final example here for the if statements. And so, we are taking the code that we did for the last example, just kind of adding to it. And so we have this variable here, needs correction is equal to 3. First, we check if needs correction is less than 1. If it's not, so we say that this first conditional here is false. So we ignore this code here. Okay. Then we check else if. So else if needs correction greater than 7. And so we plug in 3 for needs correction. We check if 3 is greater than 7. That is false. 3 is less than 7. And so we can kind of get rid of that statement there. And so since the first two conditionals in this if statement are false, we then finally go down to the else part, which says that needs corrections equal to 4. So after this code here, our variable needs underscore correction will have a value of 4. And that only happened because all of the if statements and else if statements return false. Okay. Any questions on else statements? Yes.
If you were using this for like the simplex method, would it be like if my coefficients in my like objective function are greater than 0 or non-negative, then like it can't be improved also.
Yep. Yep. That's definitely one way to think about it. And you know, as we kind of go through a lot of these algorithms, you know, first we're going to kind of explain the algorithm kind of in human speak English terms in terms of how you know a human would go about it, and then the next step would be to program it. And so going through kind of things like that is you know really helpful. And in fact, we'll be doing that basically for the next. So if statements are really important. So whenever you're programming any kind of algorithm, you know, an algorithm is almost never just a straight shot. It's not the same recipe every single time. There's always kind of decisions you have to make throughout the algorithm and do different things depending on the conditions. And so the if statements is going to be kind of key to our code because our algorithms are also going to have branching paths. So to make a branching path or to make a decision or do something different, you need an if statement in there. Okay. Oh yeah, you can do that too. Yeah, so that would be like a nested if statement. Yeah, and in fact, you know, we'll have if statements inside loops, and so we'll have if statements inside loops, loops inside loops, loops inside if statements, and so it's gonna be pretty chaotic. Yeah. Some of the examples I was looking at them before the class. Some of the examples that I have like 200 lines of code just for one output, and for a very simple problem too. So it gets pretty nutty sometimes. So, read your code as if it were an English paper. Okay, so we're done with loops. We're done with if statements, and so let's go ahead and move on to loops. Okay. So there are two types of loops that you can do in programming, but in essence, they both kind of accomplish the same thing. It's just that the way that they do it is kind of different. Okay. And so the whole idea with the loop is to kind of repeat a segment of code, you know, multiple times. Usually many times, hundreds, thousands, millions of times. Okay. And so the for loop, the way the for loop works is that we are going to repeat a set amount of code a fixed amount of times. And so the for loop kind of knows ahead of time how many times that code is going to be repeated. Okay. Okay, and so the syntax of a loop kind of looks like this. So, you know, just like its name, we're going to use the word for. Okay. So that's how you initiate it. So you type for in your loop. Okay. And then what you do first, and so I'll go over the loop index variable in a second. But the kind of the more important part is kind of these parts right here. And so you have to tell a loop where it's going to start and where it's going to end. Okay, so that's the start and stop values. And so for the start values, you know, usually we set the start equal to 1. Okay. Right, just because, you know, we just kind of naturally start counting up in 1. And then your stop will be just how many times you want the. And so we look at this example down here. We have 4 index is equal to 1 to 5. Okay. What this is telling us here is that this loop is going to repeat itself 5. Which by itself, you know, doesn't seem like it's that impressive, right? And so, you know, if the body of your loop is just 1 line, right? You know, sometimes it might be easier just to kind of copy and paste that code. But you know, when we're doing algorithms like we are in optimization, you know, sometimes you're going to repeat a set of code, you know, literally millions of times. So you're not going to be copying and pasting a million times in your code. You're going to want to write a loop to it. Okay. And I think you know, loops is kind of where you know, people kind of have a hard time, especially when you're kind of learning how to time, because I think when you're kind of reading a program without loops, you can kind of read it from start to end, and it's kind of more or less kind of straightforward. So once you're writing loops, okay, you kind of have to keep track in your head, what's kind of happening in each iteration of the loop. Okay, because sometimes, especially in an algorithm, you want the algorithm to do something different on different iterations of the loop, or different stages of the algorithm. Okay, so you start to have if statements and then loops, and it's kind of crazy. But the main thing, the kind of the most important thing about it here is actually this part here that I kind of skipped over. So that part right there is what's called the loop index variable, and that's kind of how the program kind of keeps track of which iteration of the loop that it's in. Okay, because the for loop knows that it's going to repeat 5 times, right? But while it's running the for loop, the program kind of has to keep track of what loop am I on right now? Second loop, am I in the third loop? Okay. The index variable is the way that the program kind of keeps track. Okay. And so the way that you can think of the index variable is that it is a variable, and so it's very much a variable that you can interact with. You can reference it. I wouldn't recommend resetting its value inside the loop, because that gets kind of crazy a little bit. But we can certainly reference it inside the loop. Okay. Okay. And so basically, each time the loop completes, right? And so every time you kind of reach the end of the loop, the index variable will increase its value by. All right, so let's look at this kind of very simple example here of this formula. And so we have 4 index that goes from 1 to 5. Okay. And so this tells us here that that loop at the bottom is going to repeat 5 times. Okay. And then on each iteration of the loop, the index variable it'll start at the value of 1 on the first iteration. And then on the second iteration, it's going to have a value of 2. Third one's going to have a value of 3. Then 4, then 5. Then once index reaches 5, it's going to exit the loop. Okay, and so let's see what we're doing here. And so we created a vector here. Okay. And so what this line of code here, so we kind of skipped it just because we're not doing vectors all that much in this class. But what the zeros function will do here is it'll create an empty, what I call an empty vector. Okay. And so it'll be a vector with 5 entries, but every entry is 0. Right. And then what we're going to do in the loop is we're going to set the values for the vector to be 2 times its index. Where the first entry here has index 1, second entry has index 2, this third entry, fourth entry, and fifth entry. Right, and so what you can see here is that what we're setting is that the loop vector at index, whatever at the current position that we're in, is equal to 2 times that index. And remember that index is a variable that kind of counts up every iteration. So on the first iteration, index is equal to 1. And so what we're saying is that the first entry in this loop vector is equal to 2 times 1. So it was 2. Then the loop completes, and then it goes up to the next iteration. So then it has a value of 2. Okay. So we said the second entry in loop vector is equal to 2 times 2, which is 4. Here. Okay. And so on and so forth. Let's say third entry, the fourth entry. Okay. So that's the basics of loops. And so loops are basically what you use when there are a lot of ways that you can kind of interact with loops, a lot of ways that you use loops. Especially when you're writing algorithms, and so we'll be seeing a lot of loops in this class. Okay. All right. Any questions on this so far? Okay. All right. And so here's kind of a breakdown of the logic of. Okay. And so again, I think when people are kind of learning the program for the first time, kind of following what's happening inside a loop, especially as the loop starts to repeat itself kind of multiple times, I think that's part of what makes programming. What I would kind of recommend is when you're writing a loop, actually really kind of follow the logic of what's happening each time, and then see how all the variables update as you go on each iteration of the loop. Okay. All right, so for example, let's look at this past example here. And so for the first iteration. Okay, we're starting out with the loop vector has all zeros here, so 0, 0, 0, 0, 0. Okay. And so on the first iteration of the loop, our index's value has a value of 1. Okay. And so after we execute that first line of code in the loop, then we're setting the first entry equal to 2, and then everything else is equal to 0. We haven't gone. Then on the second iteration of the loop, then our index value is 2, and then we set the value of the second entry equal to 4. Okay. And then we do it the same for the third entry, the fourth entry, and then finally the fifth. Okay. All right, so doing something like this, where you're kind of, I call this kind of unpacking the loop. Okay, and so you're kind of really breaking down kind of what's happening on each iteration of the loop. This is really helpful, and this is something that you'll, it seems like a pain to do. A lot of programming, just kind of understanding what's going on is a pain. It's a pain. I know, but something like this I think is really helpful for kind of getting that intuition for what the loop is doing, what the program's doing. Really kind of write it out and kind of break it down step by step, and then that's kind of what helps you build your intuition. Ultimately, kind of what makes you better. Okay. So unpacking the loop is really. All right, so let's talk about nested for loops. And so a nested for loop is nothing more than just a loop inside a loop, okay? And so you can basically just repeat a loop again, and it this is where kind of things get really chaotic. Okay. All right, and so the general syntax for a nested for loop looks something like this. So we have usually the outer loop we call the outer loop, okay? And then we have an inner loop on the inside. All right, and so the way to kind of interpret this, or the way to kind of look at it, is that each time the outer loop updates, okay, so each time the outer loop goes to a next iteration, the inner loop will complete a full cycle. And so let me just put some numbers here. So let's say that the outer loop here is going to repeat 3 times. Okay. Whereas the inner loop, let's say we repeat the inner loop 4 times. Okay. Right, so outer loop 3 times, inner loop 4 times. Okay, and so the way this code is going to be read is that we're going to get to this line of the code here. And so this line of code, MATLAB will say, okay, I'm going to repeat this code 3 times. Okay? And so this entire outer loop is going to repeat 3 times. But each time this outer loop updates, or each time it kind of increments, this inner loop here completes a full cycle. Okay. And so that means, and so if we can kind of track this, so let's kind of unpack this loop here. So let's say that for the outer loop, our outer index, we'll call this O, is equal to 1. Okay. And so during that iteration here, where O is equal to 1, the inner loop will fully loop. We have 1, 2, 3, 4. So the inner index goes through an entire cycle of 1, 2, 3. Then after that, the outer loop will update. And so it'll go on to this next value of 2. Okay. But then after the outer index goes to 2, then the inner loop will also still do a full cycle. 1, 2, 3, 4. Okay. And then finally, we can repeat this one more time. So 3. So the inner index is 1, 2. Right. And so what does this mean for our code on the inside? So the function that we have on the inside here is this one, which is kind of a generic function. Okay. And so let's count and see how many times this line of code here will be completed. Okay. And so this line of code here will be completed each time the inner loop updates. And so each time it runs through an iteration. And so if we count the number of times that I goes up, right? So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. That means the nested function here will be 12 times. And so you kind of just multiply kind of the stopping values for both the outer and the inner. Okay. So that's, of course, that's a very simple example, but once you kind of get more complicated code, it can be a lot more stuff. And so when we do have nested loops, I like to think about the hands of a clock. That's kind of my analogy, right? So like an analog clock. And so, think of the outer loop here as the hour hand, and the inner loop here as the minute. Okay? And so every time the minute hand makes a full rotation around the clock, then the hour hand kind of tick over. Okay? And so that's how you kind of think of nested for loops, is that each time the outer loop goes one tick or one iteration, the inner loop does a full rotation, does its full cycle. And it continues that until the outer loop. Okay. Any questions on nested loops here? Okay. All right. So here's a good example. And so actually let's do a different example. This is a matrix. Okay. So let's kind of combine the two concepts that we learned. And so well, I guess technically three concepts. So we've learned kind of three main concepts today. So we learned about variables, how to set variables, how to manipulate variables, how to use them. We talked about if statements, and so if statements are ways to kind of tell your program to do kind of something different depending on the conditions. Okay, and then we have for loops. For loops are just ways to kind of repeat a set of code. All right, so let's look at a combination of these things. And so let's see what happens when we have an if statement inside a for loop. So this is a very kind of central kind of concept that we're going to use a lot. Usually the way that we're going to do this is that whenever we have an algorithm, we're going to have a loop of some kind because we want the algorithm to kind of repeat many times. And then inside the for loop, we have an if statement to kind of check certain conditions. First of all, to see whether or not the algorithm is complete, but also maybe we want to see if the algorithm wants to do something different, depending on the situation. Okay, so let's look at this example. And so for this first line of code here, we can see we create an empty vector. Okay. Right. And so that empty vector is going to have 20 entries. Okay, so it's a 20 entry vector here, and they're all 0. And what this code here is going to do is that it's going to populate different entries in that vector depending on if the index is an even number. Okay. And so for the odd number entries, we don't want to do anything with this code. We only want to update it or change the value if the entry has an even. Okay. And so since we're going to check 20 different things, we're going to visit 20 different entries of the vector here. We can have a for loop that moves 20 times. And so that's what this line of code here says, is that we're going to move up to 20 times. And then inside the loop, we need to check to see, if we're at an even number index. Okay, and so the way we can do that is we can say if we're going to use a special function here called mod. And so mod is a special function which kind of takes two arguments, and so what it does is it takes the first argument, divide by the second argument, and then it actually returns the remainder. It doesn't give you the division result. It gives you a remainder. And so this is really helpful because if we take mod of something and modulate it by 2, if that number in question is an even number, when we divide it by 2, it's not going to have any remainder. So fortunately, we're talking strictly kind of integer operations. And so, for example, if we take 5, we take 6 mod 2, we get 3. If we take 5 mod 2, that's going to give us 2 remainder 1. Okay, so it always gives us the remainder. And this is a great way to check, if a function is even. And so what we're checking is to say if mod vector index and 2 is equal to 0. Okay. Right. And so if that statement is true, and so if the division of our index and 2 gives us no remainder, okay, so remainder 0, then we can go in and change the result. And so if that's true, then we set the value of that vector equal to some value here. Okay. If not, then we ignore it. And so by running this code, we get the following result. And so we see that all the odd number indices 1, 3, 5, 7, 9, 11, and 13. Okay. all of these are zero, because we ignored them from the if statement. But all the even number entries have a value here, because they satisfy our if statement. Okay. So, this, again, this is a very common concept that we're going to see throughout the classes. Having an if state, having a for loop or some kind of loop kind of represent an algorithm, and then having an if statement in the middle, kind of checking certain conditions, and then doing certain things if those conditions are. Okay. Any questions on this? So I have a couple examples here, but I think let me show you kind of an example optimization algorithm just to kind of give you a sense. Let me increase the font. Can you guys see this this code? Okay, everyone in the class. Okay, so this is one of the first examples that we're going to do in multi-dimensional, I call non-linear programming. And so it's a fairly short code, so it's only 40 lines of code, and that's with a lot of comments from me too. Okay, and this method is called the Monte Carlo. And so I was actually telling my wife about this method last. That's what I like to do. I like to tell my wife the joys of optimization algorithms as we're eating. She's still married to me, so don't worry. And so Monte Carlo has probably one of the coolest names for an algorithm, but it's literally the dumbest algorithm that you can think of. So, here's our objective function. And so you can see here we have a two-dimensional optimization. So we have a variable x1, okay, and a second variable x2. Okay, so not that different from kind of what we've done. Okay. And we want to find the optimal value for this, for this objective function. Okay. And so the way the Monte Carlo method works, if you're familiar with the term Monte Carlo, you'll know that it's the site of a very famous casino in Europe, actually in the south of France. And so very much like the casino, this method here is kind of centered around the concept of gambling. Okay. And so in order to run the Monte Carlo method, you have to have bounds, right? And so you have to have some constraints on the variables. And so what this constraint here is basically saying the value for x1 has to be between -2 and 2. Okay. And so we're constrained to be within that range. And then x2 is also scaled between -2. And so we kind of know our feasible region here. So our feasible region is kind of in this box of -2 to 2 on both x1 and x2. Okay, so not that different from what we've seen. Okay, and so the way the Monte Carlo method works is that, all right, we have our region here. So actually, let me go ahead and draw it. X1, x2. And so our feasible region is kind of this box right here, right? Where this box goes from -2, 2, -2. And so our optimal solution is somewhere in that box. Okay. All right. And so the way the Monte Carlo method works is, all right, I know my feasible region. Let me print this out on a piece of paper. Let me put it on my wall. Let me take just a shit ton of darts and just throw them at the board, right? And then just whichever one ends up the best is the most optimal solution. Okay. Monte Carlo is literally just do random shit until we find the most optimal solution, right? That's literally the algorithm. I'm not even kidding. Okay, so let's look at this code. Okay. All right, and so what we're going to do is we're going to start our iteration loop. Okay, so a lot of our algorithms are going to look like this. So we have a loop. Okay? So that's going to tell us that we're going to repeat this set of code, many times. And so we're going to compute a random number. And so we have two variables here, R1, R2. And ran is kind of a special function within MATLAB that computes a random number between 0 and So some random decimal between 0 and 1. Okay, we can then take that R1, R2, and then compute them or kind of scale them into our range, right? Because we know x1 and x2, they're not between 0 and 1, but they're between -2 and 2. And so what these lines of code here is that they scale it. Okay? And so what this will do is that it'll take a random number and it'll convert it into that same random number between -2 and 2. We then take x1, x2, so you can think of x1, x2 here as kind of our guesses for x1, x2. Okay, so that's just the random dart that we just happen to throw on the board. Okay. We compute our objective function. Okay, so we plug those values into our objective function. And then what we do from here is that we check and see if this trial solution, if this dart that we just randomly threw is better than the last guess that we did, or whatever the best guess that we had before. So we have an if statement here. So we say the if statement if our trial solution is less than our best. Okay. And so in other words, if F trial is more optimal than F best, then we say that. And so we say that x1 best is equal to x1 trial. Okay. And so here we're updating the value of variables inside our function. X1 best is equal to x1 trial. X2 best is equal to x2 trial. And then F best is equal to F trial. And so then we end the loop and then we come back to the top. But if the guess that we did was not better than FS, and so we end up with the guess that was somehow worse, then we just ignore it and then we just go on and move on to the next random guess. All right, so a very kind of simple code, but you can see how something like this would be kind of impossible to do by hand. So if you look, and so you can see the loop here is a for loop, having to repeat n times. Okay? And so the value for n here I've set to be 90 million. And so, 90 million guesses, even though this code is very simple, it's basically impossible for a human to do 90 million guesses. Right? This can only be achieved by code. And so let me go ahead and run it just so you can see. And you'll see how quickly it completes. Okay, that was maybe like 3 seconds. Okay, so it took MATLAB 3 seconds to run 90 million guesses on the subject. It takes me longer to say that than it does for MATLAB to actually run the code. And so that's kind of the power that we're working with here. So, and so our thinking for these algorithms is going to change. We're up to this point in the class, when we describe the methodology, maybe a classic method or maybe simplex method, okay? We always kind of describe them in a way, and we kind of ran it in a way that is kind of feasible for humans to do. Okay. Now, from this point in the class, your thinking about these algorithms has to kind of shift a little bit. Where we're going to be describing steps, we're going to be talking about algorithms that, on the one sense, might make sense in terms of you can execute those steps. But practically speaking, it's not really good or not really practical for a human to kind of execute these things. Okay. And so you need to think about these algorithms in terms of how do I instruct a computer to execute this? Because a computer can do all these things like random guessing, it can do checks, it can do addition, multiplication at speeds that kind of far exceed kind of human. Okay. And so you can see from there, let's see what was the best result. And so the best result here was x2 best was 1.5 and x1 best was -1. And so our optimal solution here was x1 1, x2 is equal to 1. Okay. So any questions on that example there?
Yeah. If you increase 10, could you potentially get like a more option?
Oh yeah. And so that's the thing with Monte Carlo is that generally, the more random guesses that you take, you increase your chances of getting a more optimal. But in this case, -1 and 1.5, that's pretty much the optimum. 90 million is actually kind of overkill. So the only reason I set it to 90 million was so that I did have a chance to talk and actually say something while it's running. But we can actually reduce this quite a bit. And so instead of 90 million, let's say it's equal to maybe 10,000. And so if we run the same code again, it's already be finished by the time I come here. And so from this, it got us an x1 best of minus 0.9713, x2 752. Okay. So not quite exactly -1 and 1.5, but it's still pretty close. And we did it at the fraction of the cost. So yeah, the more, of course, the more trials that you do, the more accurate.
Is it gonna like converge to a value? Like
Yes. Yeah. So generally, yeah, Monte Carlo will always converge to the true. It's funny really, because Monte Carlo has a very interesting kind of reputation, because it almost always works. And so, which is kind of fun to think about, just doing random shit, just somehow it works. It'll work eventually. But the way a lot of other algorithms are kind of defined, you're kind of always competing with Monte Carlo. And so if you're writing a new optimization algorithm, at the very least, we should beat Monte Carlo. And if you're not beating Monte Carlo, then so Monte Carlo is kind of the worst it can get, but it'll always work eventually. It's just that in a lot of practical situations, you can't run 900 million finite element simulations. Like that would take. That's why you can have more efficient algorithms. For a cheap objective function, Monte Carlo works. Yes.
Are there cases where like the optimization algorithm is a while loop instead of a for loop?
Oh yeah. And actually you can rewrite this code to actually be a while loop too. And so actually, for a lot of the examples that we're going to do in class, I kind of give you a taste of both, so while loop. And so in this case, for Monte Carlo, it makes sense to use a for loop just to make sure that you have kind of a cap. And so you're just not doing random stuff for a long time. Because Monte Carlo doesn't have a way to kind of self-terminate. But a lot of the other algorithms that we're looking at, so actually the simplex algorithm is a good example. So the simplex algorithm can self-terminate, because once your objective function has all positive coefficients, then we can terminate. And so for the simplex algorithm, you can use a while loop and just keep repeating until you get all positive. Yeah, but you can actually do Monte Carlo. Just that you have to keep track of a counter internally, and then once that counter exceeds that value, that absolutely. And a lot of these algorithms you can do either. Right. Any other questions on this? Okay, all right. And so that's just a basic review of MATLAB. Although we just kind of cover the very basics of MATLAB, and so these are just kind of you could kind of think of these as kind of the very basic tools, and we're going to use these basic tools in lots of kind of really creative ways. So we're going to be kind of continuously reviewing MATLAB, and I have a ton of example codes to kind of show you, and so this will be a process that we'll kind of continue building on for the rest of the class. But at the very least, before we start, we need to know about variables. We need to know about if statements, kind of what they represent, and groups. Okay. And then we'll kind of build on this from there. Okay, so let's go ahead and wrap it up a little bit early today. And so next time I see you guys will be Tuesday for the midterm exam. And then after Tuesday, we'll kind of start on this stuff. All right, so thank you guys for coming today. If you have any other questions about the midterm or anything, please send me an email or come to office hours. Oh, so my office, I know some people went to my my new office, which is not populated yet. So my office is still in CS. And so my office is still on 5th floor CS on this building. So if you went to my other office in engineering today, I apologize. I should have kind of clarified that beforehand. Still. All right. So I'll see you guys next week. Any final questions before I go back?